Inflammatory pain is, by definition, an immune response. So mast cells and macrophages and these guys, neutrophils, are all immune cells. They're in the skin. And if skin gets damaged, the end result is invasion of more macrophages, mast cells, and neutrophils. They release chemicals that are designed to recruit even more immune cells to show up. And some of those are familiar to you. Histamine. That's one of them. Prostaglandins are an important component that we'll talk about. These other guys, tumor necrosis factor, the interleukins, endothelins, those are signaling molecules, cytokines and chemokines that are meant to attract and stimulate immune cells to fight off any infection that might have occurred here. Okay, so fine. That's what we got. Problem is that some nociceptors have in their tips receptors to histamine and prostaglandins and interleukins and tumor necrosis factor. So we've already looked at how the binding of bradykinin and of ATP can work to make it possible for TRPV1 to open at temperatures less than 42 degrees centigrade. So we've talked about those two. And I want to talk about this guy. Talk about prostaglandins, because in the end, those are fundamental to what goes on in the nervous system response to this immune activation. So I'm going to tell you that prostaglandins are important for waking up a kind of nociceptor that we call a mechanically insensitive afferent. Afferent is just another name for a somatosensory axon. So you can record in a peripheral nerve, you find an axon, no matter how hard you lean on the skin, pinch it, poke it, doesn't really matter. This axon, this afferent, won't respond. So that means the dorsal cell that gives rise to this axon has in it things that won't respond to simple mechanical stimuli. So what does make them respond? And the answer is prostaglandins. Once they bind prostaglandins at their tips, for example, if this was one of these guys, as soon as it binds prostaglandins, it goes from being mechanically insensitive to mechanically supersensitive afferent. It will respond to any kind of mechanical stimulus, even if it's perfectly innocuous. So let's deal with that. Let's talk about how it is prostaglandins get made and how it is they wake up a set of nociceptors that are called mechanically insensitive afferents, because under normal conditions they do not respond to any mechanical stimulus. How then do prostaglandins come to be, since they're so important for inflammation and for wakes up mechanically insensitive afferents? Well, when the plasma membrane of a cell is damaged, let's say a skin cell, just any old cell in the skin, there are enzymes in the extracellular fluid, a population of phospholipases. Now, there are phospholipases inside a cell, but these are phospholipases that are found outside a cell. A lipase breaks down fats. Phospholipases break down lipids that have phosphates attached to them. Well, you see them all over the plasma membrane. So, okay, phospholipases attack these phospholipids that have been allowed to exist out here, that have been liberated by the damage to the plasma membrane. The phospholipases turn these phospholipids into one sort of signaling molecule called arachidonic acid. Okay, we're not going to worry about that as anything other than a precursor for prostaglandins, because all you need to do is have another enzyme that's present in extracellular fluid called cyclooxygenases, the COXes, show up, and they will cleave one fragment of arachidonic acid to produce prostaglandins. Okay, so now you have a situation in which tissue damage leads to the production of prostaglandins. It will institute an inflammation and it wakes up the mechanically insensitive afferents. How do you stop all this from happening? Because this waking up the mechanically insensitive afferents is what's producing inflammatory pain. Well, what's a drug that you've used for inflammatory pain? How about ibuprofen? Some of you may have taken aspirin, naproxen, Aleve. All of these are drugs that work by inhibiting the COXes. They come along and they make the COX stop working for a while at least, and as a result of that, arachidonic acid's made, but prostaglandins are not. So these drugs are called non-steroidal. They're not steroids, because steroids will also work nicely. Some steroids will work nicely to suppress inflammation. Non-steroidal anti-inflammatory drugs. NSAIDs is what we call them. That's a U. Non-steroidal anti-inflammatory drugs, NSAIDs. And they're widely used, right? So I can't remember the last time I went a week without taking ibuprofen for something. Right? So okay, fine, you'll get there. And steroids again. So if you take a corticosteroid, or if it's injected into a joint that's inflamed, it works really, really well. These guys do as well. So they work by suppressing the enzyme, the cyclooxygenases, that turn arachidonic acid into prostaglandins. So that's how they show up. Now, what do they do? What is it that prostaglandins do? I'm using inflammatory bowel as an example of inflammatory pain, but it could be in the skin or any place else. And you'll notice that here's a set of afferents going out into the world. They're in red, called MIAs, mechanically insensitive afferents. Again, let's take the bowel. The bowel can distend when it has food in it. It's not the least bit unpleasant to you, right? You may stop eating. You probably should. But, it's okay. You'll live with it. When the mechanically insensitive afferents wake up, you cannot tolerate. It is so painful to have any kind of gut distension. Any kind of food in the bowel at all becomes very painful to these people. So the MIAs will not respond, no response to mechanical energy. It can be gut distension. No, that's no response, not due response. No response to mechanical energy, mech energy. The gut can be distended. We can go ahead and prod the skin. As long as it's innocuous, it's not any big deal. In fact, even if it's really, really intense mechanical stimulus, if you take pliers and just mash down on your hand, mechanically insensitive afferents, they have nothing to do. They say, no, I'm not going to bother. But add prostaglandins, and what you wind up getting is a mechanically super sensitive afferent, an afferent that will respond even when the mechanical energy is innocuous. Yeah, you know this. If you sprain an ankle, all you have to do is stand on it and it hurts like the dickens, and that's because you've woken up the mechanically insensitive afferents that innervate the tendons, the ligaments in your ankle. That's all you need to do. These guys now become super sensitive to any kind of mechanical stimulus, and as a result, these nociceptors generate action potentials with even the slightest amount of mechanical energy, all because of the presence of the prostaglandins.